Your Ford truck has factory settings that are quietly grinding your engine and transmission components to dust. Most owners have no idea that the very options configured at the factory to make these trucks pass federal regulations are the exact features designed to shorten the lifespan of your vehicle. For over 15 years, I have torn down these engines and transmissions in my shop, and I have seen the catastrophic wreckage caused not by owner neglect, but by factory default programming. Today, I am exposing 5 factory settings or features that are causing hidden damage, waste, or inefficiency without you knowing. Setting number 3 has caused massive mechanical failures across thousands of trucks, and setting number 1 is so deceptive that owners actually think it is beneficial when it is doing the exact opposite. Let's get into it. Setting number 5 is the factory low RPM transmission shift programming, specifically the aggressive skip shifting protocol built into the 10R80 10-speed automatic transmission. If you drive a modern F-150 or Ranger, you have undoubtedly noticed that your truck loves to shift from first gear straight to third, and then immediately into fifth, rushing to get the transmission into 10th gear by the time you hit 45 miles per hour. Ford markets this as an efficiency optimization feature designed to maximize your miles per gallon by keeping the engine operating at the lowest possible RPM. But here's what Ford doesn't tell you. This setting forces your engine to constantly lug under high load conditions, creating a brutal environment for your internal components. When your truck is cruising at 35 miles per hour in 7th or 8th gear, the engine is turning at a measly 1100 to 1200 RPM. The moment you press the accelerator to pass or climb a slight incline, the computer resists downshifting to keep fuel consumption low. This forces the engine to handle immense load at an incredibly low rotational speed. In direct injection EcoBoost engines, this exact scenario triggers low-speed pre-ignition, or LSPI. Fuel is sprayed directly into the combustion chamber under extreme pressure, where it mixes with microscopic oil droplets on the cylinder walls and ignites prematurely while the piston is still traveling upward on its compression stroke. This creates a massive, uncontrolled pressure spike exceeding 1,200 pounds per square inch. I have personally disassembled engines with under 40,000 miles where the piston ring lands were completely shattered and the cylinder walls were gouged because of LSPI caused by engine lugging. Furthermore, at 1100 RPM, your mechanical oil pump is operating at its lower threshold, producing less volume and pressure. You are subjecting the connecting rod bearings to maximum mechanical force while providing them with the thinnest possible oil film thickness. Inside the transmission itself, forcing large gear jumps means the internal clutch packs must slip excessively to smooth out the transition between widely spaced ratios. This continuous clutch slippage generates localized heat spikes that cook the transmission fluid, degrading its viscosity and dropping its thermal breakdown threshold long before the standard service interval. The microscopic friction material, sloughed off during these slipping events, migrates directly into the ultra-tight clearances of the main valve body, leading to the erratic, harsh shifting and eventual torque converter failure that plagues these units. To stop this invisible destruction, you need to change how the vehicle manages its gears. You do not need to buy anything. Instead, make it a habit to use the progressive range selection buttons on the side of your shifter to lock out the higher overdrive gears, specifically 8th, 9th, and 10th, when you are driving in stop-and-go city traffic. Alternatively, switching your drive mode to Tow Haul or Sport mode completely reconfigures the shift logic, forcing the transmission to utilize every single gear sequentially and keeping your engine operating in a healthy, safe RPM band between 1800 and 2200 RPM, where oil pressure is optimal and cylinder pressures are balanced. Setting number 4 is the default-enabled auto start-stop system, a feature that Ford markets as a brilliant environment-saving, fuel-sipping advancement. The factory setting dictates that whenever your truck comes to a complete halt at a red light or intersection, the engine instantly shuts down, restarting the moment your foot begins to lift off the brake pedal. Mechanically, this feature is creating the exact environment that destroys your engine's primary journal bearings. Your engine relies on hydrodynamic lubrication to keep moving parts from wearing out. When the engine is running, the crankshaft spins rapidly inside the main and rod bearings, drawing a continuous wedge of pressurized motor oil between the spinning steel journal and the soft Babbitt bearing lining. This creates an oil film layer roughly 2 to 3 microns thick, ensuring that there is absolutely zero metal-to-metal contact. The components are literally floating on oil. However, the exact millisecond that the auto start-stop system kills your engine at a stoplight, oil pressure drops to absolute zero. The heavy crankshaft settles down through the thin oil film, making direct contact with the bearing shell. When the light turns green and the computer commands a restart, the engine cranks, while under boundary lubrication conditions, meaning raw metal is grinding against raw metal for that initial rotation before the oil pump can re-establish pressure. A conventional truck driven without this feature will experience roughly 50,000 start-stop cycles over its entire useful lifetime. A modern Ford truck with the factory auto start-stop setting left active will easily experience over 500,000 start-stop cycles in that same time frame. I have pulled oil samples from these trucks that show highly elevated levels of copper, lead, and aluminum. And I have personally inspected crankshaft thrust washers at 60,000 miles that were worn down to the bare backing material because the engine was starved for protection hundreds of times every single day. The minute amount of fuel you save while idling is completely erased by the premature wear inflicted on your internal bearings, not to mention the extreme electrical stress placed on your starter motor and your expensive absorbed glass mat battery, which must endure constant deep discharge cycles to run your electronics while the engine is dead. The solution is simple but requires consistency. You must train yourself to press the physical auto start-stop override button located on your dashboard every single time you start the truck. If you want a permanent fix that you do not have to think about, you can install a simple plug-and-play inline delete module behind the switch matrix, which safely remembers your preference to keep the feature turned off. Protecting your engine bearings from catastrophic friction wear without altering any other factory safety parameters. We have already unmasked the factory programming that slashes your transmission's lifespan and grinds your crankshaft bearings down to bare metal. But the hidden mechanics of vehicle deterioration go much deeper than just transmission gears and stoplight cycles. Setting number 3 is the factory-programmed 10,000-mile Intelligent Oil Life Monitor interval. If you rely on your truck's dashboard to tell you when it is time for an oil change, you are actively participating in the slow, invisible suicide of your engine. Ford's marketing materials claim that their advanced algorithm constantly calculates oil degradation based on operating temperatures, idling time, and driving habits, allowing you to safely stretch your service intervals up to 10,000 miles or 1 full year. But here's what Ford doesn't tell you. This algorithm is calibrated to get the vehicle past its powertrain warranty period, while lowering the perceived cost of ownership for fleet buyers, completely ignoring the long-term structural survivability of the engine. In the real world, particularly with the twin-turbocharged, direct-injected EcoBoost engine family, 10,000 miles on a single oil fill is a mechanical death sentence. Because these engines utilize direct injection, fuel is sprayed at ultra-high pressures directly into the combustion cylinders, which inherently causes a small percentage of raw gasoline to blow past the piston rings, a phenomenon known as fuel dilution. By the time that oil has been in your crankcase for 6,000 miles, it is heavily contaminated with fuel, which violently shears the oil's viscosity down. A robust 5W30 oil is rapidly thinned out until it possesses the protective properties of a 0W16 oil. At the exact same time, these engines utilize complex, oil pressure-driven variable cam timing phasers and long, snake-like timing chains that rely on pristine oil quality to function. As the diluted oil passes through the intense heat of the turbocharger's center sections, microscopic carbon soot particles are baked right out of suspension. These abrasive soot particles act like liquid sandpaper inside your engine. They migrate into the tiny oil feed ports of the hydraulic timing chain tensioners, clogging the internal check valves. Deprived of proper hydraulic tension, the massive timing chain begins to whip and rattle against its plastic guides during cold starts. The abrasive oil rapidly wears down the pins and rollers of the chain itself, causing it to stretch beyond its physical limits. I have personally replaced hundreds of stretched timing chains and phasers on trucks that were meticulously serviced exactly when the factory dashboard monitor reached 0%. By that point, the oil had completely lost its total base number, meaning its ability to neutralize corrosive acids had dropped to nothing, allowing chemical etching to pit the polished surfaces of your camshaft journals and grinding your valve train components to dust. The damage is entirely cumulative and invisible until the day your truck throws a check engine light for timing misalignment, leaving you with a $4,000 repair bill. The solution to this engineered obsolescence is dead simple. Throw the factory dashboard monitor out the window. Never let your engine oil cross the 5,000-mile mark, or 6 months, whichever comes first. If you regularly tow heavy loads or idle excessively in traffic, pull that interval down to 3,500 miles. I have pulled oil samples at these midpoint intervals, and the lab analysis proves that dumping the oil before it shears and loads up with carbon soot is the single most effective thing you can do to ensure your engine easily crosses the 200,000-mile mark without a major mechanical teardown. Setting number 2 is the Factory Smart Charging S WeStem default configuration, specifically the Battery Management System Target State of Charge. When you look at your truck's charging system, you assume that the alternator is constantly working to keep your battery completely full and healthy, just like vehicles did for decades. Ford markets their Modern Battery Management System, or BMS, as an advanced eco-friendly feature that reduces engine drag and improves fuel economy by cycling the alternator off when it isn't strictly needed. But under the surface, the mechanical reality is destroying your expensive battery and starving your vehicle's massive electronic infrastructure. The factory programming instructs the computer to maintain the battery at a target state of charge of only 75 to 80% rather than a full 100%. The system utilizes a current sensor mounted on the negative battery cable to monitor exactly how much juice is going in and out, and the moment it hits that 80% threshold, it commands the alternator to drop its output voltage down to a meager 12.6 to 13.1 volts, barely enough to run the truck's electronics, let alone pack any more power into the battery cells. This means your battery is spending 100% of its life in a permanent state of chronic undercharging. Mechanically, this induces accelerated chemical sulfation inside the battery plates. When a lead-acid or absorbed glass mat battery sits below a full charge, sulfur molecules in the electrolyte chemically bond with the lead plates, forming hardened lead sulfate crystals. Over time, these crystals permanently coat the plates, drastically reducing the battery's surface area and plugging its ability to accept or deliver electrical current. This chronic undercharging is the exact reason why owners find themselves replacing their expensive AGM batteries every 2 years instead of getting the 5 to 7 years of service they should be getting. But the damage doesn't stop at the battery terminal. Modern Ford trucks are incredibly network dependent, packed with dozens of interconnected computer modules that communicate via high-speed controller area network buses. When your battery voltage drops below 12 volts during a cold crank because it was never fully charged, it triggers a cascade of transient low-voltage spikes across the entire electrical network. These voltage drops confuse the vehicle's modules, throwing intermittent communication codes, causing sudden glitches in the infotainment screen, and inducing erratic behavior in driver assistance safety systems. I have personally diagnosed countless phantom electrical issues where modules were misbehaving, and the root cause wasn't a faulty component. It was a battery that had been chemically crippled by the factory charging logic. To reverse this structural efficiency loss and save yourself hundreds of dollars in premature battery replacements, you need to reconfigure the system's target parameters. While you can temporarily bypass the feature by disconnecting the small BMS sensor plug at the negative battery terminal, doing so disables certain factory convenience features, like accessory power timers. The correct permanent solution is to use a standard diagnostic interface cable and open-source configuration software to access the vehicle's central configuration module. Within the software, navigate to the battery management system parameters and manually change the factory target state of charge from 80% up to 95%. This simple electronic adjustment forces the alternator to properly maintain the battery at its true optimal chemical capacity, completely eliminating plate sulfation, extending your battery's life dramatically, and ensuring your truck's complex electronics always receive a stable, clean supply of clean power. We have already exposed the programming that starves your bearings, thins out your oil, stretches your timing chains, and permanently degrades your battery through chronic undercharging. But none of those settings match the pure, calculated deception of the final factory configuration on our list. Setting number 1 is the factory-programmed buffered dashboard gauge cluster logic, specifically the coolant temperature and oil pressure indications. If you are like most truck owners, you glance at your dashboard gauges to ensure everything is running in the safe zone, trusting that if your engine starts running dangerously hot or loses oil pressure, that little needle will swing toward the red zone and warn you long before catastrophic failure occurs. Ford markets their modern digital and analog instrument clusters as precision monitoring stations that give you complete command and awareness over your vehicle's vitals. But here's what Ford doesn't tell you. Those gauges are not real gauges. They are nothing more than glorified, computer-controlled dummy lights designed to keep you calm and ignorant until it is far too late. The factory programming utilizes an aggressive smoothing and buffering algorithm that decouples the physical needle from the actual live data stream coming from the engine sensors. For instance, the coolant temperature needle is programmed to rise to the exact center of the gauge when the engine reaches roughly 165 degrees Fahrenheit. It will then freeze dead center and refuse to move a single millimeter, whether your actual coolant temperature is a perfectly safe 180 degrees or a searing 235 degrees. The computer deliberately masks these massive thermal swings because the manufacturer knows that if owners saw their actual engine temperatures fluctuating rapidly while towing a heavy trailer up a steep grade, they would panic and flood dealership service bays with complaints. The needle is hard-coded to remain perfectly stagnant until the cylinder head temperature sensor crosses a catastrophic threshold, typically around 245 degrees Fahrenheit. Only then does the algorithm release the needle, sending it rocketing into the hot zone at the exact same instant the engine coolant over temperature. Warning flashes on your screen. Mechanically, by the time that needle moves, your engine is already cooking. At 240 degrees, aluminum cylinder heads begin to warp, losing their structural clamping force and instantly breaching the combustion seal of the head gaskets. The extreme heat causes the piston rings to expand until their end gaps close entirely, forcing the rings to bind tightly against the cylinder walls, which scores the bores and snaps the piston lands apart. Even worse is the oil pressure gauge logic. On most modern Ford truck platforms, the oil pressure sensor on the engine block is a simple binary on-off switch, not a transducer that measures actual pressure. The switch is calibrated to close when pressure rises above a pathetic 5 to 6 pounds per square inch. When the computer sees this switch close, the factory programming commands the dashboard needle to sweep gracefully right to the middle of the gauge, indicating to you that your oil pressure is absolutely perfect. The needle stays perfectly stable in the center, whether your engine is making 60 pounds of pressure or a dangerously low 8 pounds of pressure. I have personally hooked up mechanical master pressure gauges to trucks idling in my shop where the dashboard gauge showed flawless, healthy pressure, while the actual mechanical gauge revealed the engine was struggling at 7 pounds per square inch. At that critically low pressure, oil cannot properly reach the overhead camshafts or adequately lubricate the twin turbocharger bearings. The bearing journals are actively tearing themselves to pieces, generating immense friction heat and filling your oil pan with fine metallic debris, yet your dashboard tells you everything is completely fine. This deceptive buffering logic turns your primary defense system into an invisible trap, transforming a preventable low-pressure or high-temperature scenario into a total engine replacement event with zero advance warning. To strip away this dangerous layer of automotive deception and protect your truck from unexpected catastrophic failure, you must bypass the buffered cluster logic entirely. You cannot fix this by changing a setting in the factory infotainment screen. Instead, you need to utilize an electronic data link monitor that plugs directly into your truck's OBD2 diagnostic port. These aftermarket monitors bypass the dashboard's buffering software completely, tapping directly into the raw, unedited controller area network bus data stream to display your true, real-time digital cylinder head temperatures, transmission fluid temperatures, and actual engine parameters. Alternatively, for a completely seamless look, you can use specialized diagnostic configuration software to alter the instrument cluster module's core coding. By rewriting the specific hex blocks within the cluster's software, you can force the digital screen to display the exact live numeric temperature values directly above the factory coolant and transmission gauges. This simple electronic modification completely destroys the factory buffer, giving you the precise, unedited mechanical truth about your engine's thermal health before a heavy load turns into a cracked engine block. Every single feature and setting we have exposed today shares a common, unsettling theme. They were engineered to optimize a corporate metric on a spreadsheet at the absolute expense of your truck's long-term mechanical survivability. The factory programming is designed to get your vehicle through the factory warranty period with glowing remarks, leaving you to hold the massive repair bill the second that coverage expires. But now that you understand the hidden mechanisms driving this cumulative, invisible wear, you hold the power to change the narrative. Saving your truck from its own factory settings doesn't require thousands of dollars in aftermarket parts. It simply requires a fundamental shift in your daily habits and a few basic electronic adjustments. Take control of your machine. Lock out your overdrive gears in heavy traffic. Manually disable the start-stop system on every single drive. Throw away the 10,000-mile service delusion. Correct your battery's target state of charge, and monitor your true, unbuffered engine data. You paid an immense amount of hard-earned money for the heavy-duty hardware sitting in your driveway, and you deserve to get 20 years of dependable service out of it. If you are ready to stop playing by the manufacturer's rules and start protecting your investment with proven, hands-on mechanical truth, make sure to hit that subscribe button